Okay, to the pretty much the last part of our notes, relationships between lines, segments, and rays. So there are really four types of relationships for lines and segments and rays. Anything that can go on forever, or at least for a finite distance, and that looks like a line or a piece of a line. So intersecting means a combination of two lines, rays or segments, and they intersect at exactly one point. So if you look at the figure here, right, and actually it's pretty much the same figure as we have here, right? So here's our figure again. So they have to be in the same plane, and actually they don't have to look like, they don't have to be in yellow or green. There are actually other planes in here that you can't see where they connect. So in this figure, two intersecting lines, I could just go GJ and HI, or I could go DC and GJ, or DC and HI. Do you see all of those are intersecting lines? I could also go EF and FI. Those are intersecting lines. EF and FI. Okay? Perpendicular, a combination of two intersecting line segments or rays which meet at right angles. So they have to meet at a right angle. Actually, the example I just did worked well. Or I could go GJ and HI. Why do I do that? So perpendicular lines are just a special type of intersecting line. Okay? Parallel. So parallel means they should lie in the same plane. You should be able to slide them over without having to rotate them. And they should be parallel. They should never intersect. So I could go EF and HI, for example, or I could go FI and EH. Or I could go AB and DC. In fact, I'll do those because they're a little slanty. So I'm going AB and DC. If I look at my notes, AB and DC. See how they're parallel. The way we do that notation is that we say, AB and DC, excuse me, AB, DC. See this little symbol here, and I forgot to mark it up here? That little symbol means parallel. So AB and DC are parallel. Let me fix this, or it's going to drive me crazy. AB and DC are parallel. Let's pick another set of lines in here. We will do another set of parallel lines. Let's do GJ and EH. And EH. Okay, now skew lines are two lines that never intersect, so that are non-coplanar. So skew lines are two lines that are blank but never intersect. So they are not parallel. I mean, they are not perpendicular. They are not intersecting, really. I'm sorry. And they're not parallel, not intersecting. Oh, wait, not, oh my goodness. Never intersect, and they are not parallel. There we go. Got that straight now. So, like, I wouldn't want EH and GJ. They don't intersect, but those are parallel. What's the cool thing is I can do EH and AB. Those are skew lines. They never intersect. Another one I could do is DC and FE. So as long as they're not in the same plane and they don't intersect. So we'll go on to example 3. If two lines intersect, they intersect at two different points. Now I'm going to make this easier to say at exactly, just to make it a little easier. Is that sometimes, always, or never true? Well, let's do two lines intersecting. Can I ever make it do 2 points? If I did 2 points, this would have to curve around. So there's only 1 point if they intersect. Now you could have two lines on top of each other, but that would really be an infinite number of points, not just 2 points. So we'll say this is never true. Can AB be another name for BA? Well, let's see. Let me do AB. Notice how it has a line segment notation, right? Is that the same as BA? Yes. on lines, it doesn't really matter the direction. We just take both directions forever. So this is always true. If two rays share a common endpoint, then they form a line. Now remember, we did do the ray like this, right? So we have two rays. I'm going to do an opposite ray. So that is true, right? They form a line. Is that the only way I could do two rays that share a common endpoint? So this is false, and this one is true. So it is sometimes true. All right, so now I'll leave you with the reflect question. You learned the formula for circumference of a circle, C equals pi d, in 6th grade. Pi d is the diameter. By measuring the circumference and diameter and looking at the ratio of the two measurements, complete the following thought. I believe that the circumference, the formula for circumference of a circle is or is not, so pick one, a postulate because. All right? And don't forget, a postulate is something that can be said to be true without proof. You don't really need to do work to show it. All right. And there's the information on postulates.